All right, so we'll get started right away. The talk will last for 30 minutes and we'll take 15 minutes question and answer, Q&A section from anyone who has questions from what we're about to learn and discuss. If there's any questions you have during the presentation, during the talk, you can use the Q&A section of the platform to queue in your questions, and I'll check the questions in interval. So at the end of the talk, you can use the chat to interact and ask questions as well. So feel free to share how you feel about the talk and also ask questions to quickly understand. So we'll get started right away. My name is Trust Onyekwere. I am a blockchain architect, currently working with the DevRel team at Bonds to educate and support the blockchain developers who are interested to build dApps quickly. At Bonds, we are simplifying the dApp development process by done. Okay, just a moment. Sorry, let me fix my slide. All right, it's done. At Bonds, we're offering ready-made smart contracts across different use cases for developers to build across NFTs, DeFi, and DAOs, and other use cases as they seem to build. Today, we're going to look at how to architect blockchain solutions in different use cases and what it takes to select a blockchain and how to maintain whatever selected blockchain you've selected to build your dApps going forward. We're going to take a look at overview of the blockchain, look at the key considerations, things to consider when designing or building a blockchain solution. Look at examples of success stories or use cases in various industries. We'll take a look at the best practices for architecting and implementing blockchain solutions, and then we'll summarize and conclude before we head over to Q&As to take questions that you may have during the conversation and talk. Blockchain technology is not new to those in tech, especially developers, with the whole Web3 buzz. It is a decentralized ledger, a distributed ledger system that enables transparent transfer of data and assets across different parties without the need for intermediaries or third parties like the banks or the government. And so far, we've seen different innovations that have sprouted out because of blockchain. It has evolved beyond cryptocurrencies, and we need to understand that there's been an evolution of the web from Web 1.0 that was read only to Web 0.2 that was read and write, and then we are now in the Web 3 era alongside the Web 2, of course, which is read, write, and own. And Web 3 uses blockchains. That's what powers the Web 3 ecosystem. And the blockchain powers cryptocurrencies and NFTs to give back power and ownership to the users. And we're seeing blockchain has moved beyond just cryptocurrencies and has found more potential in different use cases like finance and banking, supply chain management, healthcare, real estate, and government. Now, in this talk, we're going to dive deep into the potential use cases of the blockchain, explore how it can be designed and implemented to meet different specific project and business needs and requirements. We'll also cover key considerations for developing blockchain solutions. At the end of this talk, you have a good understanding of how the blockchain can be architected and how to leverage it to transform and make more impact in projects and ideas that you want to build upon. The blockchain space has been growing, and we're happy to see that most developers, we're happy to see organizations building successful and useful dApps, decentralized applications, and blockchain apps leveraging the blockchain technology. We'll take a look at each of the industries and see how they use that. The first is in finance and banking. The blockchain technology has played a huge impact in finance and banking in the financial industry to reduce transaction costs, increase transparency, and try to mitigate fraud. An example of a company that has successfully implemented the blockchain in finance is Ripple. Ripple is a blockchain solution that is a blockchain platform that allows and enables real-time cross-border transactions with low fees than traditional banking system, traditional payment systems. And so they've built their own blockchain called XRP Ledger. That is what they use to build upon their payments platform on the blockchain. Another is the JB Coin by the JP Morgan Bank. They have built a digital solution that enables is used for instant settlements of transaction between clients. What you can see on the screen, a description of solution enables instant transfer and clearing of multi-bank, multi-currency assets on the permission blockchain or distributed ledger as it's called. These are two examples. There are many more, but these are two examples of how the blockchain has been used to simplify, increase transparency, and processes in the financial industry. And of course, we're seeing more improvements with DeFi. Is there a comment? Okay. So we're seeing more improvements in DeFi innovations across different sectors, especially in the financial sector. The second industry that has taken a stronghold of the blockchain technology is supply chain management. Supply chain management has been used to enhance transparency also and traceability in supply chain management. The first company organization that has done this well is Walmart. Walmart has implemented the blockchain input supply. Is a microphone that is unmuted. Hold on. All right. So Walmart has implemented blockchain to track origin of produce. So it enables them to track and trace contaminated food and where they came from and remove it from their shelves. And this has helped Walmart in their processes and managing of the supply chain better. Another example is the IBM Food Trust. The IBM have Food Trust is a solution built on the blockchain that enables tracking of food products from the farm to table, reducing the waste and ensuring food safety. These are two examples of how the blockchain technology has been used in the supply chain management to simplify, increase trust, especially with food security, and also traceability of where the food came from, how it's terminated, and how to manage that supply chain to ensure that they can be tracked, and of course, it's all transparent. The healthcare sector is also one sector that's leveraged on the blockchain heavily. An example is Medical Chain. Medical Chain is a health startup, a company that has built a blockchain solution that enables patients to store and share medical records, and thereby reducing the risk of errors and improving patient outcomes. Another example of people who have used blockchain to improve healthcare is Medrec. Medrec built a blockchain solution that enables patients to save, log, store, track symptoms, and share their medical records to healthcare providers, and thereby reducing the risk and fear of medical records getting leaked or exposed. The real estate too has had a fair share in how blockchain can simplify processes and improve business outcomes. Croppy is a solution that has enabled the blockchain platform, that's used the blockchain platform to enable their platform. And they have used that by building a real estate solution on the blockchain that reduces the need of intermediaries between lawyers and title companies, similar to what Ubiquity has done. And Ubiquity also built a solution on the blockchain. They pride themselves to be the leading blockchain company for real estate, title, and escrow. And so they are a solution built on the blockchain that enables secure and transparent recording of property titles and deeds. These are examples of how different industries have leveraged the blockchain to scale. And the government too is not left out. We've seen different use cases of blockchain in public sectors to increase transparency, reduce corruption, and streamline processes. Example is Estonia. Estonia has leveraged the blockchain to improve voting. And Dubai too is exploring the use of blockchain technology to identify verification and improve verification and identification, which enables residents to access government services more easily and securely. All these are examples to illustrate the potential that the blockchain has had and is still having to transform various industries and processes and outcomes. As developers, as architects, as product managers or entrepreneurs, the question would be, how can we build our own desired use case on the blockchain? How can we leverage any of these examples to build solutions of blockchain on for healthcare, for food chain management, for real estate, or even for finance and banking? To do that, there are 5 things to consider during, before, during, and after designing and developing blockchain solutions. We'll take them one after the other. Well, the first is choosing the right blockchain platform. There are a whole lot of blockchain platforms. Ethereum on its own has EVM-based chains, Polygon, Avalanche, BSC, Asta, and a whole lot. We have Solana, we have Neo, we have OpenChain, we have quite a lot. Ripple too is also there with the SRP ledger. Which is the best platform for building blockchain applications? If you're asked this question for developers in the call, which or what is the best blockchain platform? What would be your answer? What is the best blockchain platform? Probably take some time to think about that, or share your answer, your opinions on the chat. What is the best blockchain platform in your opinion? Is it Ethereum itself, or is it Polygon, or will it be Solana, or is it Ripple, or is it Avalanche or BSC? What would you think is the best blockchain platform? Fantastic, fantastic. Yes. So the answer is depends. It's similar to asking what is the best car? What is the best shoe? Well, it depends. It depends. It depends on the purpose. There is a popular phrase used in architecture in the 80s that says form follows function. It means that merely by looking at the form or the shape or the structure of a building, it tells you what the building is meant to be used for. And so if you look at a building with a structure, you could easily guess and say, oh, this is for a residential building. Or you look at a building and say, oh, this is a warehouse. There are different forms of buildings, and the forms that means or follows the function. In similar case, there is no best blockchain platform, but the question is, what is the problem? What is the requirement? Just like, who said that? Yeah, so Nori mentioned that on the chat. It depends on the project specification. I think Daniel did as well. Depends on the problem. So the problem, the purpose, determines what blockchain to use. It determines if we need to build this on the public blockchain, on the private blockchain, or on the hybrid blockchain. It depends. Ethereum is fantastic for different use cases. We've seen Ethereum being used to build different dApps, and we've seen Ethereum being used to build a whole lot of thousands of dApps. The cost of cryptocurrency, finance, and quite a lot. It's popular alongside EVM-based chains like Polygon, Avalanche, and the rest of them. Ripple is also a blockchain. Ripple is recommended to be used for financial dApps, financial applications. Because over the years, Ripple has been known for wanting and wanting alone financial transactions. And they've built their own blockchain called XRP Ledger, simply dedicated to handle financial transactions. And so if you're building a financial application, it will be wise and okay to check out Ripple for your project. Another is open chain. Open chain was solely designed to handle supply chain management. And so if you're building, want to build a similar use case to Walmart or IBM Food Trust, it would be ideal to look at the way of open chain. So the problem determines what blockchain to be used. That's the first answer to that question. Well, it depends. Depends on the problem, depends on the use case, depends on the function, depends on how the app would be structured entirely, depends on how users will use and interact with the application. We have the new blockchain as well, mainly for grant programs. So trying to build crowdfunding. New has a supported blockchain for that. So the problem will determine what blockchain to use. The second, that will determine what blockchain to use or how to design the architecture of your application, is looking at the consensus algorithm and impact to your solution. There are a whole lot of there are a whole lot of consensus mechanism for the blockchain, but three most popular is proof of work, proof of stake, and delegated proof of stake. There has been opinions that proof of stake has more security than proof of work. And so it depends on what the problem you're trying to solve looks like to choose what consensus algorithm you want to use for your own use case. Algorand has come up with a pure proof of stake, PPOS. And the reason for this is simply there is something we call the blockchain trilemma. It says that there are three needed values of any blockchain: security, scalability, and decentralization. The blockchain trilemma states that no blockchain can offer all the three. A blockchain can offer only two and lack in one. It's more like saying you have security, scalability, and centralization, but you need to pick two. And so a blockchain that is so good at security and so good at decentralization may be lacking in scalability. A blockchain can be so good at scalability, so good at security, but can be lacking in decentralization. So a blockchain has to choose two and lack in one. Now, pure proof of stake by Algorand is saying that our blockchain gives you all three. Or it's not an advert for Agora, but you could check them out. So it depends. If your blockchain heavily requires security, then you look for a blockchain that has more security and more scalability. If you're looking for a platform, a blockchain platform that offers a whole lot more decentralization for your use case, then you go for one that has that. If you're looking for a blockchain that dedicates and supports more of scalability, you can look for that. So you need to know which one to sacrifice given your use case. And that is what the blockchain trilemma is all about, that no one blockchain can give you all three values. They only give two and lack or offer very low value of the other one. The third, the third thing that needs to be considered when designing and building a solution on the blockchain is how do we manage data storage and management? The blockchain technology stores data or handles transfer of data and assets a whole lot. And so it is essential to look at how do we store data, and factors such as data security, privacy, encryption, redundancy should be taken into account. So any blockchain that gives a whole lot more of privacy, encryption, and manages data more could be a preferred blockchain to use. So consider what blockchain offers and what kind of storage mechanism do they have and the privacy to store the data. The fourth is security and privacy. Since blockchain involves the transfer of assets, security needs to be taken very seriously. It's important to implement secure coding practices. We'll take a look at that later on, such as encryption, such as ensuring that the solution is built to relevant regulations. So security is also very important. And since smart contracts are stored on the blockchain and execute automatically, security also needs to be top priority. Smart contracts can be vulnerable to various security attacks. It could be some vulnerabilities on the code, on the blockchain itself. So it's important for developers to use secure coding practices and follow best practices. We'll look at that very shortly to ensure that smart contract is secure, and that increases the privacy also. It's also good to look at the history of the blockchain. Has that blockchain platform had security breaches in the past 2 years? Has there been any news of a hack or a compromise to any of the data previously? That could also give you some idea of how secure and how private any of those blockchains seem to be. The fifth to consider is gas fees. Smart contracts on the blockchain require gas fees to execute. Gas fees is a unit of measurement that represents the computational costs of executing a contract on the blockchain. Different chains or different smart blockchains have the different gas fees and they charge for fee for gas. So if you're building, remember that to write on the blockchain, meaning to add to the blockchain or to change the status of the blockchain, to add data on the blockchain, you need to pay gas fees, you need to sign transactions. But to read, which means to consume what has already been added, you don't need gas fees. So if you're building a dApp or a blockchain application that requires users to always add and update the blockchain status, you have to consider what blockchain has low cost and less expensive than the others. Because users could abandon the solution if they have to pay high gas fees every single time they have to sign a transaction or add to the blockchain. So that can be another factor to consider when choosing and looking for what blockchain solution to use or platform to use rather. The sixth is scalability and performance factor. Performance is also very crucial. So it's important to look for what's the speed like? Is the traffic always jammed? Is it slow in transactions? These are things we want to look at. Can it scale? Can it take a number of users at one time? How many nodes can this be able to come to sign transactions? So looking at that also can help you to choose and determine how to structure the solution on what particular blockchain you intend to use. The last for this is consider the community. What is the community of this blockchain solution like? How many developers are supporting this? It's important because the number of developers engaged will determine, okay, these are developers and users and contributors to this blockchain. They can provide valuable materials, resources, and collaboration opportunities for anyone who's currently working on that particular blockchain. So it's important to consider, is there support for the blockchain? Is it new? Or has it been there for a long time? What's the strength of the community before you can begin to choose and build on that particular blockchain for your own solution? So these are the 7 considerations to look into, especially when you're trying to build a new use case or trying to copy existing use cases, but also for your own particular unique, solution or problem you're trying to solve. So there is no best blockchain platform. It depends on what you want to use it for. It depends on the use case and depends on the problem requirements. After choosing a blockchain platform, and we've started building the blockchain application, and we've launched or about to launch, what are the best practices that we need to architect and put in place to ensure we are launching a usable, a secure, and of course, scalable blockchain solution? The first is understanding the business requirements. Does this application really need a blockchain? We've seen over the past few months and years, there's been this buzz about everyone trying to build a blockchain application, a blockchain for this, blockchain for that. But not all of these solutions or require business objectives need a blockchain. If the problem or the application needs to solve a problem of speed, then the blockchain may not be the best option to use for that project. If the objective of the application is to increase security, then the blockchain can be used. Or the ideal objective of the application or the solution is to improve trust and transparency, and the blockchain will be the best to be used. So not all business requirements, not all use cases, not all problems require the blockchain. It's important to know if this problem needs the blockchain or not. If it does, that's beautiful. That's fine. We can work on it using the previous questions we've just asked and answered before trying to build the architect solution. The second is building or designing for scalability. Blockchain is in the early stages of implementation, and we're so happy and eager to see lots of people and companies spearheading these applications. And scalability can be a challenge that needs to be addressed. It's important to design the solution with scalability in mind, such as using off-chain solutions to reduce the burden on the main platform. There are a few solutions that have decided to build a hybrid dApp or a hybrid blockchain application. They divide half of the burden of functions is done on the blockchain and half is done off-chain to reduce the burden of the functions and applications being born on the blockchain. So it's good design for scalability. Look at what can we sacrifice. So remember that no one blockchain has all three values all figured out. They give two and lack in one. And so for a platform that offers scalability and security and decentralization, which means they could be lacking in security. And so it could be wise to look at that and find how to reduce and share one on-chain and off-chain to reduce the burden on the blockchain and design for scalability. The third for developers especially is to use coding practices. Using coding practices. It's important to implement best and secure practices such as regulations. Best practices for smart contract design include using appropriate access controls, minimizing the use of external libraries, and carefully validating all inputs and outputs. Just like any other software that you're trying to build, smart contracts should be developed using secure coding practices. This also includes using standard programming patterns, avoiding vulnerabilities, and always trying to follow industry standard security guidelines. Another best practice for smart contracts is also implementing emergency measures. It's important for developers to have a plan in place for handling potential security breaches. This may include having emergency stop mechanisms or the ability to freeze and update the smart contracts in the event of any critical um, vulnerabilities. There is a hard kill. Is it hard kill? I think it's called a hard kill, where smart contracts automatically killed. Is it a hard switch? I've gotten the word. Is that a hard switch or a hard kill? A switch kill, a key switch, any of those ones. But it simply means there is a feature for smart contracts that automatically kills it on the blockchain. If there's an event of any vulnerability, it automatically pre-programmed on that already. So these are a few secure practices that can be used to secure the smart contract, and of course, know that solution you're trying to push on the blockchain is secure. The fourth is using smart contract design patterns. Once a smart contract has been designed and developed, it's important to audit. So smart contracts should be audited by independent security experts. We have blockchain security experts. They should be the ones to audit it, to review the code for potential threats and security flaws. Auditors too can be a combination of manual and automated tools. There are a few tools that automate the auditing of smart contracts. But of course, for to be more sure and secure, we can use them both. Human and machines can do that as well. It also good to implement factory patterns and what we call the state machine patterns. It's used to have a smart contract design simply to ensure that it can be easily reviewed and threats can be spotted easily in case it needs to be changed as well. Test and deploy. We have the test net, we have the main net. So the test net is for testing, running on free gas to test out the idea and measure for vulnerabilities before moving to the mainnet. So testing smart contract is crucial to ensure that it's well designed and secure, to ensure that what has been designed and is testing. It's important to test the smart contract thoroughly before deploying on the blockchain. So like I said, there could be a testnet and a mainnet. Developers can use testnet to test and try. But once they are sure that this is going to work, they can push to production and push to mainnets for real gas fees to be used. So always test and test and test before deploying. Using standard libraries. I think we mentioned earlier to avoid excess use of external libraries, especially the ones that are not vetted and the ones that have not thoroughly been audited. It would be wise to use solely Open Zipline already gives pre-designed smart contracts. And so use standard libraries, the ones that you're sure and vetted, and not use any libraries that you see to put on the smart contracts. Lastly is monitor and maintain. Just like any other solution, once you deploy, we have to monitor and maintain. Once blockchain solution has been deployed, it's important to monitor and maintain it to ensure that it continues to meet the requirements and the objective of why it was deployed. Regular maintenance, updates, patches should be performed to ensure the longevity of the solutions. So if you have chosen a blockchain platform, always follow up on that platform to ensure that any new updates will likely, will not affect the solution drastically. Remember when Ethereum went from proof of work, proof of stake. For those already on Ethereum, they were skeptical to know what will happen if this moved from proof of stake. So it's always good to be updated to start industry news and get updated to ensure that what you've built on the blockchain can be correctly remain secure over time as you're trying to maintain and monitor and improve where need be. If we follow all of these practices, you can ensure that your blockchain solutions is well designed, secure, and efficient. Of course, you can't do it alone. As a team of different engineering, there are different people in the team. But as an engineer, you also have a say in how it's being designed. Architects also have a say. But it's good to understand the overview of how smart contract blockchain solutions rather are being designed efficient for business use cases. This will help to maximize the benefits of the blockchain technology and ensure that your organization or ensure that your project solution stays ahead of the curve. It's 32 minutes already, and we're, yeah, 32 minutes already, and that's fine. So, in conclusion, the blockchain technology has tremendous potential to transform a whole lot of industries. And developers are one of those at the forefront of bringing to life a whole lot of theories about the blockchain by building a usable dApps and usable blockchain application. It's important to know how to really use the blockchain across different industries, asking good questions to ensure that we're choosing the right blockchain for the right solution and scaling as need be. So continue to explore the potential of the blockchain technology, stay up to date to latest developments and best practices in the field. If you do all of this, it will definitely help to widen the gap and unlock the full potential of the blockchain and build solutions that will drive innovation, efficiency, and value across a wide range of industries. Thank you very much for your time and for listening. I would take the questions. Okay, so I'm looking at the questions. All right, so I'm looking at the questions right now in the chat. So we have Frederick. How do you differ? What is a public blockchain? All right, so everyone. Okay, justice. Okay, it's fine. I think Harvey has to do with both. Okay, you think connections. All right, so I'll answer the how can you get in touch with manual or tutors? Okay, so I'll answer the question from Frederick. How do you differ? What is a public blockchain and a private blockchain? So yeah, Justice mentioned a difference. I also like to give more context to that as well. So the fast answer would be that private blockchains is closed and not everyone has access to rights on the blockchain. So it's confined, not open to everybody. While the public blockchain is open to everyone. And then it gets confusing, especially when you now look at permissioned and permissionless blockchain. And so we'll take it bit by bit. But the first is understanding that the private blockchain is the public blockchain, right? Let's look at the public blockchain. Public blockchain is open to anyone who wants to join and participate. So everybody is open to everyone. You can access the network, you can view transactions on the network, you can validate new transactions by mining new blocks. Ethereum is an example of a public, sorry, is an example of a public blockchain. And these blockchains are transparent and they're secure as well. And they offer high immutability value since everybody can validate the transactions. Why private is a permissioned system or network. So unlike public, where anyone can access all the data and view, access, validate, the private is only restricted to a specific group of people who have been given permission to participate in that network. And so private blockchains are often used by businesses and organizations. So it's similar to what Hyperledger is doing. So Ethereum is for public, Hyperledger is usually for private. So private blockchains are usually used for enterprises, businesses, to share information that's sensitive between themselves. The advantage of private blockchain is that they offer high levels of privacy and control over the network, which can be important for certain reasons and applications. Right. So that's difference between the both of them. Is that clear? Then a hybrid, now the hybrid is not a combination of both. It's open to everybody, but only a few out of those people can be able to have permission to do extra on certain permissions. So it's more like everybody can come. Not everybody has given access to everything. So there's a small group of people who have access to everything while others have a portion of it. So that's the hybrid, combining both of them together. Okay, so Daniel asks, how, there's another question here, sorry. I'm into this topic. How did you start your career as a blockchain architect? How did I? Okay. What do you recommend after this? Okay, let me start from Julia's question. I am new to this subject. How did you start your career as a blockchain architect? So it will start by defining what or who is a blockchain architect. We all know building architects are those who I want to build a skyscraper, and they take their time to look at the requirements. How would the skyscraper look like? What do we need to achieve the skyscraper? What are the just look at everything required to get the skyscraper up, and then give it to those who do the actual work, why they stay back and monitor and ensure the architecture is being implemented. In a similar case, blockchain architects are bringing business use cases to become technical requirements. So looking at what needs to be done on the blockchain, or we need to build a corporate payroll system on the blockchain that pays employee cryptocurrencies at the end of the month as salaries. That's the idea and solution. Architect is not looking at what do we need to build this? Who do we need to build it? Do we use Ethereum? Do we use Polygon? Or do we use Solana? Do we use Ripple? So it's looking at how to architect the whole solution from start to finish. How do we send the money? Do we use the payment splitter smart contract? Do we use this? So it's looking at the architecture, right? So to become a blockchain architect, obviously, you need to understand how the blockchain solutions work, how the blockchain development space work. It's recommended to have at least a few experience with writing smart contracts, or a few experience with how developing of software actually works. And then you can now move into managing the whole solution from start to finish. At some organizations, a blockchain architect also manages developers to build a solution. And so you build the architecture, you're giving developers, and you're managing them to build a solution from start to finish. So that is what a blockchain architect looks like. To start, you must first understand how the blockchain works, solutions of the blockchain, a little of project management, and how developers build, and that could be how you can start your career from there. Second question say, I hope that is clear, Julia. What do you recommend after deciding which blockchain platform to use for a project? Use existing solutions or learning how to build one from scratch? Okay, good question. It depends, right? So I think it's also applicable here. It depends. There are specific use cases that require you to build from scratch. Why there are existing solutions? So I would say my personal recommendation is if there are existing solutions that you want to use for your DApp or blockchain application that exists in open source, ensure, like we've discussed, it has a good community, it's trusted and audited, you can use it. But if the solution you want to build is a unique use case, it requires you to build yours from scratch. Build yours from scratch and don't use open solutions. So it depends on the solutions, the sensitivity of the information to be passed in the blockchain, and the use case of that blockchain heavily. It depends on that. So I would recommend if there is a solution from a trusted body or platform, you can use them. But if not, you can build yours from scratch and ensure that you have internal team auditing and making sure it's actually working well. So how can we get in touch with manual and audited automated smart audits? How can we get in touch? So there are a few platforms. I will share the few platforms in the comment section of this talk after it's done. But for manual is basically means you're done with the smart contracts. Engineers who are specifically designed for security of smart contracts will do a manual review on their own. So it's always good that you give an external person who's not part of the development team to review. Because most times, if developers are giving their own contracts to review themselves, they can omit some certain things. So it's always best to give to someone new who did not build the smart contract, because they can see, or she can see the smart contract from a holistic view and make corrections. So a manual person is basically an engineer who is specified with security of a smart contract. Engineers are done, give it to him or her, and they review the smart contracts. Automated smart contracts are they are platforms, right? That you just have to put in, just like you verify. If you're familiar with Etherscan, so Etherscan or any of the blockchain explorer have their own separate way of verifying smart contracts. It's similar, where you put in the API of the smart contract, the smart contract address, the optimization number, and a few other parameters to be passed in there, and then it helps you audit it. I've forgotten the exact names of those platforms, but I will send them on the comment section after the talk ends. Okay, I hope these questions were clear enough. We have how much? Oh, 45 minutes on the dot. Okay, so I think that will be all. So thank you very much. In case any questions comes up, you can leave it on the chat, on the comment section after the talk ends. Then I could follow up from there. On Twitter, we could talk. Blockchain is best for building AI apps. Okay, so there's the last question I want to give attention to. Which best AI apps? Well, AI apps, it is similar to any other use case, right? So it depends on what use case is. So AI is basically saying what which blockchain is best for software apps or software projects. It's almost the same thing, right? Because there is no really much of an intersection that determines which blockchain fits the AI project. But it would be a lot easier to say, oh, which blockchain fits a gaming application, because into the game you have exchange of tokens rewarded to the users. So the question will now be, what is the use case of AI app? What are we intending to do inside AI app? And what does it involve? That will not determine what blockchain to use. Like example of the gaming application, we know for games there could be tokens won by the player, and the tokens can be used to buy NFTs or whatever inside the ecosystem. And so that would be easier to say what blockchain to use. But what blockchain is best for AI apps? The question doesn't really tally, because almost the same application that we just discussed that can be used to answer the question, what is AI app going to do? What's the use case? What's the requirements? That can help us to know what blockchain to use. So it depends. That's the answer. It depends on what the AI app is doing. Okay. So thank you very much, everyone. I appreciate the time and the questions asked. Hope to see you guys some other time, and we'll talk more about the blockchain. Thank you very much, and enjoy the rest of your day. Bye bye.